Okay, what's good about this? Good, thanks. 10-1. Send one day one, I guess. It might be only one day, I believe. 10-1. 1-1. I have the other class in my brain. This is chapter 1. Wow, good start. Um, and what's good about it, as I finish what I was trying to start saying, it is a little bit of review. But now it's the time to have your graphing calculator. If you don't have one, it may be we still have to kind of put together this final exam because there have been changes in the course a little bit. But there are questions we're going to cover this year that you have to have your graphing calculator. So those that got by first semester, I may have brought out some graphing calculator things that we could do, but it wasn't really graphing calculator necessary. And then the final exam, it was no graphing calculator at all. So we do have to have one. So we'll have to work out something on that. If you don't, and we got to get used to the button presses. So you need to bring it every day in case we do, hey, this is what the graphing calculator can do, then you can play along with the notes. If you don't, then you're never going to know how to use it and be behind. So it's just really the fact of the matter. Okay, so notice the directions. It says solve the equation algebraically. Then what does it say next? And graphically. Let's get this out right now. The graphically is for you to get practice. And do you have to do it on every single one? It's up to you how you want to do it. I will share, and make sure I do share, what if I told you on a test to solve it graphically? What do I have to show you? Well, what you'd have to show me is a picture with the appropriate window that you chose. The windows they could be different depending on what you chose to make sure you see the graph well enough. And then the highlighted points of where you got your solutions from. I'll do that once. You do not have to do that for your homework tonight. There's a section that says solve algebraically. Then there is a section that says solve graphically only. Maybe for that one, show a sketch real quick and identify your window values. What was your x-axis min-max? What was your y-axis min-max? But not on the first section, 29 through 38. Just do it algebraically and then play around with your calculator for your own benefit. Okay, so that being said, that student right there, I'm pointing at you. How do I do this first one? Because we did this last chapter. What would be the most efficient way to do this one? I can't hear you. You're barely speaking. Oh. Good factors are good, and you forgot this name? We don't use that word. What do we use instead of distributing? Foiling. You remember who had Demas? Rejoice. Say foil right now. She's like, no, I'm not going to do it. I feel she can hear me at Central still. All right. So, no, that's actually not the most efficient way. No, the most efficient way is not foiling, not subtracting 121, and then refactoring and or quadratic formula. That takes 7 times longer than doing what for this particular setup? Square rooting both sides. This is something squared. So to undo the square, we squared it. Now back to you. Burn, burn, burn. Okay, hopefully you've listened all year long. What do we have? What do we write here? Now what do we write now that we've chosen the quickest and easiest way to do this? So what do I write? Come on. There you go. I'm actually, and then what's the square root of 121? Oh no, they don't know their times tables. It's 11. Okay, now back to this group. Bam. Don't get burned, right? That's the plus minus. Okay, so what do I do next? Subtract 11. You know what? This is how we did it last hour. Be able to do 2 things at once. What's positive 11? Minus 11. And then what's negative 11? Minus another 11. There you go. And there's your 2 answers. We could check them when we go there. I'm going to do all 4 of these now. It's going to be redundant. I'll do 2 of these 4 algebraic questions with the graphing calculator. Probably that'll be one of them, and I'll tell you what we can do. We've already done it in chapter AP. All right, next one. You haven't done anything yet. What do you think you'd do first on this one? This is what we came up with. Yeah, this is right. If we tried to factor this, these would be the numbers. I just said, boy, I can't even think of that. You know, what multiplies the fraction, and then those same two numbers add to negative 7? Ugh. The other hour multiplied both sides by what? 4. And then they tried the MA thing. And then they found out it wasn't factorable. So if it's not factorable, what am I stuck with doing? Now we're going to stick with these numbers. The other hour, we multiplied by 4. Then we did the quadratic formula. I'm going to stick with this because it still works. So go ahead and do the quadratic formula. Tell me the numbers. We'll do that offline. Okay, so we did that offline. We got the numbers in. Sure. For a C, C is a fraction, but it's taken care of when we take this times 4. By the way, what's a negative times a negative? So we got to understand that this is 7 plus or minus a root. This becomes 49 plus 3, which is 52. Now, the other hour, we multiplied everything by 4. That means all these numbers were 4 times bigger. And then they had a tougher rationalization they had to do. So it ended up being the same answer. So 7 plus or minus. What's 52? A number. Okay, well, we talked about even big numbers. 52 is at least divisible by 2. Divide it by 2, and you get 26. What's 26? Divisible by 2, and then there's 13. So this ends up being 2 2's divided out with 13 left over. This is how you break down a number, you people that cannot break down numbers. Their number, it was 4 times bigger. So is that 208, I think? Something like that. We divide it by 2. Then we divide it by 2. Then we divide it by 2. Then we divide it by 2 again. What's 4 2's divided out? 16. So now you write 16, and you write what's left over. And it's showing on the calculator as 52. This is how you do it. You guys make this too hard. All right? Way too hard. All right. And then, what's the square root of 4? 2. Does this reduce at all? Oh, my goodness. I don't know where that number came from. It doesn't. This cancels, but this doesn't. So this is the answer inexact. Now, what if they asked for a decimal? Then I wouldn't have done any of this. I would have just typed this on my calculator to get these decimals. If they asked for a decimal, I would just go ahead and type those. I cannot overemphasize the fact of this, though. And this is worth it. You think I overteach? I don't care. Because I see this crap all the time, and it drives me nuts. And then the people that don't care, oh, he's a blabbering, on and on and on. I see these mistakes all the years I've ever taught. Is this right if I type this on let's say, a scientific calculator? Oh, the scientific calculator forces that parenthesis, right? Is that right? If I type that on my calculator, yes or no? No. You know what this is doing? It's taking 52 divided by 2, then square rooting 26. Is this right if I close that parenthesis? Now we got a problem. This is where half the class still says yes, and the other half says no. Who's correct? The no's. This is taking the square root of 52, then dividing by 2, and then adding that answer to 7. Is that what's supposed to be happening? So this is what I tell my students to do all the time, so you don't have to worry about it, and it's actually fast. Press this, and then press enter. Then look at that decimal that you get, and divide that decimal by 2 last. It's fast. And that way you got all the numerator together, and you're dividing all of the numerator by 2. And that's always the fastest way. I don't care if you have a fraction button. The fraction button takes extra clicks and extra time. So that's how you can get 7.11, and then when you go back and do 7 minus 2 root 13, press enter, then divide by 2. Okay, so I just wanted that on tape. So we got 2 down. Okay, right here. Is this right? Oh, this times this equals 10, so either this equals 10 or that equals 10. You know how do people do that? There's not a 10 product rule. There's a blank product rule. Fill in the blank. 0. So, I mean, even looking at this, this is so ridiculous. What's 2 times 10, everybody? Answer the question! 20 minus 1 is? 10 times 19 apparently is 10, according to this student. Wrong and wrong. So what do you got to do about it? Distribute. Then what? subtract 10, so that we could possibly use the zero product property by factoring. Is this factorable? I think it is, because this can tell you if it is factorable. What's the M number? Let's go to you. Negative what? Yep, and then what's A? Okay, and then we'll crunch the numbers. I would stop here. I actually would not do this method. And I know many of you should not, because doesn't this have to be 2x and 1x? Good FOILers are good what? That's why I was surprised you didn't know that four-letter F word. What? All right, FOIL. We're talking about FOIL. And then what has to fit in here? A product that equals what? And then you can play with it. 1 and 10, I don't think so. 2 and 5, one of them being negative. Who knows what the answer is? 2x what? Minus 5, and then what? Plus 2. That gets me the negative 10. That gets me 4x and negative 5x. Those are the ones that are really handling factoring well. They understand the relationship. Okay, but if you don't, and sometimes it is hard. Sometimes I still do this method because it's too hard to guess and check. There's too many possibilities. Then I fall back to this. So we'll continue with that. 2x squared, we said negative 5 and positive 4. That would be the smartest thing to do, write it that way. And then you group and factor out a GCF. When you pull out an x on this one, you're left with 2x minus 5. When you pull out a 2 out of this one, you're left with that 2x minus 5. And then the 2x minus 5 is pulled out as a GCF binomial, and you're left with x plus 2 when you pull out that 2x minus 5. So they're showing that method if the factoring's too hard to guess and check. What's the final answer, though? You didn't do much. I want you to tell me the final answers. So what's x equal? And negative 2. That's the zero product property used appropriately. Okay? Done. This thing's like an object altogether. It's a negative object, so I can add it to both sides. So the student said add or subtract 1 and then square. That wouldn't have worked because, and I do want to share it, not to make fun of, it's to make a point. If you subtracted 1 and squared this would be a FOIL. And then you'd still have a square root in the equation. So what you're supposed to do is isolate the square roots. Now go ahead, student. What do you do now that it's like this? What do we do now? Square both sides. Now we're going to go to your friend. Okay? How do I square? Or what's the left side? And we'll do this offline. So we FOILed the left side correctly. Now we're online. What's the right side squared? I'll give you a hint. That's 2 times this squared. So what's 2 squared? Because someone just blurted it out over there. 4. And then what's this squared? So this one you can distribute the times because you really are squaring the 2 and squaring the square root. And that's a free x plus 4. Now what do you do? Distribute. And now what do you do? I don't know what I'm doing. Now what do you do?
Get it all to one side.
Get it all to one side. And then now what do you do? I'm going to get that done real quick. And this one's an easy factor. This is why I say you should not, if you do that long method of factoring this, you're going to make me mad. The MA is negative 15 and negative 2. So what is this factored? This should be fast for everyone. And then what are the answers? This is our 4th example, right, everyone? In the 3 previous, did I check my answers? Back in the day when I first started teaching, the students always were expected to check their answers. Check your answers, make sure you're right, and I actually should have done that in the first 3. I didn't because our math was valid and good. So I circled these answers without checking them. Look at what happens. Okay, let's actually go to the original. Let's all do this together, or by together I mean I'll speak and then you'll just stare and drool. I'm just kidding. All right. What's 5 plus 1, everybody? Hey, they said something. So 5 plus 1 is 6. And then minus 2 times, what's 5 plus 4? 9. What's the square root of 9? Did this work, yes or no? So this is good. All right, let's erase that. And I love this, and I love explaining this, and it's actually better to explain after we added to both sides. But let's just check this answer. What's negative 3 plus 1? Okay, what's negative 3 plus 4? What's the square root of 1? True or false? That's a false. So wait a minute, did we do something wrong? No? To get a square root solve for, we do have to square both sides. But for some reason, this answer didn't work. I'm going to pause for a second. Now, this is what I love. Come back up here. Remember, I squared both sides, right? Right? So let's erase this. And remember, this is just the original when I added 2 root to both sides, right? Okay, now let's plug this in here. What's negative 3 plus 1? Negative 2. What's negative 3 plus 4? What's the square root of 1? What's 1 times 2? Does 2 equal negative 2, yes or no? Does 2 squared equal negative 2 squared, though? See, this solves when we squared both sides. But the original, are both sides squared? No, we used a method to solve that gave me a false positive, a false answer for the original. That's why we use the term, this is called an extraneous solution. You remember that term? And all that means is a fancy schmancy word for you did the right math, you just got a false positive because of what you did, the method algebraically you used in order to solve. At some point in the equation solving, it's a solution for one of the lines in your work, but not the original. Does that make sense? It's not always that's the case. In this case, that's what it is. This is a solution somewhere along the lines, but not for the original. So squaring both sides gave you a false positive answer. Now, this is what drives me nuts. You better listen to this, because then people make up their own extrapolations, and almost always those extrapolations are wrong. So someone's going to say now, oh, when I have a squared equation, one of my answers is always going to fall out. False. There are times that both of these will be right. There are times that both of these will be wrong. If that's the case, what do you say if both of them are wrong? It's a no solution scenario. And that could be presented to you. Many cases where there's no solution. So it's not, don't just be, and then some people take it further. The positive works, the negative answer doesn't, because you have square roots. Not even close to being right. What's right is you have to check your answer. And it may be all of them work, none of them work, or only a few of them work and some don't. I'm talking about overall in general. Okay, now it's time for the calculator. Oh, I'm going to take a risk and try the Inspire first and embarrass myself on the internet. No one's watching these videos anyway, so it's fine. Why would we, right? So I've already tried to open it, and we'll get this all settled here to start off with. Remember what I said. Solve algebraically and graphically. For 29 through 38, you don't necessarily have to write a picture. It's for your own purposes, but you do want to go through this. All right, you do want to be able to do what I'm doing here to try to find stuff. And I'm really going to be bad on the Inspire on this. I'm going to try my best. So I'll do most of it offline. This may take me 5 minutes just to type in the equations. So I'll try to do my best. Okay, so the first thing, how do I do this? Let's just get this off. So I guess maybe we could say this is a. Do I open up a document? How do I start? What do I do? Just hit the home button? Okay, yeah. And then what do I do? New document? No, hit B. Isn't this fun? And then press enter. Okay, and then, okay. All right, we're getting somewhere. All right, and then what do okay, so this is what we do first. I do the parentheses. I do the left side. What I'm attempting to do is put this into Y1. Oh, no. It's F1 of X and then F2 of X. I want to put these in two different graphs. So, going back to this, where is the button? Okay, here it is. This is fun. Are you all right? X plus 11 And then how do I get that? Can I square? Is there a square? There's a square button. Nice. I'm glad I picked this one. And you can probably barely see this because that screen's so small, but I did do that. Now how do I do F2? What do I hit? Tab? Do I just press enter? But I want F2's graph. Oh boy. Now how do I get the F2 thing back up? Huh? Hit tab? I think it is tab. Where's tab? Tab? Boom! She's right. F2 of x. And then what do I want to type in that? 121. And then press enter. Okay, A, you're lucky you see anything. And then this is the point I'm going to make right now. Why did I not see y equals 121? It's too far. What is this high number right there that they're saying right there? What's that number up there? 7.29. When this is a this is a horizontal line that crosses through what on the y-axis? What? 121. So what do I have to do? I have to expand my window. Now, I'm not going to go through that pain on this Inspire. We'll do this offline to find out how I change my window. 12 easy button clicks. We got to the window settings. All right. So now, what do I want to change? Well, notice also, I don't really see a lot of this. Hey, what's that a picture of, by the way? X minus 11 squared, or X plus 11 squared, sorry. A parabola. Facing which direction? That's a big yawn right there. Up. What's the vertex of that? Now I'm digging into your Math 2, Math 3 thoughts. What is the vertex of this parabola, x plus 11 squared? Negative 11 comma 0. And so what I have to do is also expand my x values minimum. So this is what I mean about what your job is. You can't just be a button pusher and then the calculator does everything for you. You have to have an idea that this is a parabola going up. We're gonna talk about this in 1.3. We're gonna break down functions and basics of that and transformations and all that. It's gonna be very important so that you're more than just a button pusher. You actually have to pick windows that make this fit. Boom! That's if you were falling asleep at YouTube at home, because I just caught someone falling asleep in my class. All right. So what I'm going to do is put negative 50 just to make sure. I don't know where this is going to, show it all. All right, and then I'm going to go down to, I don't want to change the y minimum. I couldn't care less about that. I'm going to change this. Remember, it was y equals 121. I just want to make it 130. How come that didn't do anything? What happened there? Oh, my gosh, I have no idea what's going on. 1, there we go, 30. I could have swore I just did that. Enter. Boom. Now I can see the two intersections of this graph. Now, I know we didn't need this for this one, but I'm just saying this is how we do it. Now, what would I expect you to do for me if I said, all right, do it graphically, show me a picture of what happened? Remember those window values that you did. Say you just went like this. Oh, okay, let's actually find the answer. Menu. What is this? Analyze graph somewhere? Analyze graph, and then do intersection. And then all you do is go here, toggle, and open. Boom. Negative 22, 121. I got to do it again, I guess. And then menu, analyze graph. This is if you've never done this before. I don't think I've ever... What? No. What just happened there? Holy cow. What? Oh, okay. What just happened? Analyze graph. This is intersection. Sorry. I'm freaking out, man. All right, there we go. And then 0, 121. This is what I expect you to do. I'd expect you to draw that picture. Oh, I thought that was going to work. I just screwed this up. Done. I'm done with this stupid calculator. All right. So draw this. Boom, boom. Don't do it now. Put negative 50 here. Put 130 here. I don't care what that was. Negative 7 point. Just put negative 10 there. And then show the drawing. All right. Show that it crossed here. And crossed here. And then identify those points. This one was negative 22, 121. And this one was 0, 121. That's all I would need. And then me seeing the picture that you got, I know what the picture's supposed to look like. All right? And then you show that and then identify that when I plug in negative 22, I get 121 as an output value. That makes negative 22 an answer. That makes 0 an answer. Okay? Sorry for my problems with the... Okay, so now what we're going to do is do this one. Nope. Y equals with an 84, which I'm much more comfortable with. You could do one of two things. You could leave this as is and type this on your calculator. For an 84, I thoroughly suggest you never do the 0 feature. You do the intersect. So I'm going to do what I did last hour. X plus 1 minus 2 hertz x plus 4. And I implore you that you do y2 equals 0. So y1, y2. Now what I did in the other hour is to actually show this. When we zoom standard, 6, 10 to negative 10, you do have to understand that there are two pictures here. One is just covered by the x-axis. So I'm going to show you another feature on the 84 real quick to prove that. Turning off my axes real quick. That was second zoom, which is format. And then watch this graph happen again. The first one comes up again. The axes are gone. Now you can see that y equals 0, and you can see these two graphs what? Intersect. Okay, but before, with the axes on, students don't understand maybe why are you putting y2 equals 0? It doesn't even show up. It does. It's just covered by the x-axis. Anywho, second calculate, this is all you got to do. Go down to 5, which is intersect. I don't even have to arrow over close to this one, because how many intersections are there? 1. Enter, 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 until it says intersect. Now here's what I was going to say. You don't know much about what this graph should look like when it's a combination of a polynomial with a square root in it. But the previous one you knew. One of the lines was a horizontal line. The other picture was a parabola. You have to understand what the graphs are so you understand that there may be two intersections. How do we know that this doesn't come back around and come down and intersect again? The problem is we don't really know that much about this picture. If I would have added it to both sides, then I would know what x plus 1 looks like. What's x plus 1? A picture of a what? Starts with an L. Line. What's a square root look like? That's interesting. We're going to talk about that in 1.3. So you know what they're supposed to look like, so you know what your intersection should look like on the calculator. For instance, this one I'm not going to pull out a calculator. I'm going to keep the screens. Your job is not to just be a button pusher on number 40, which says, use your graphing calculator to solve. Your job is to know that a square root, wrong, that an absolute value looks like a picture of a what? V. See, this proves, if I know this is a V, then I know this part of the graph is going to keep doing what? Going up and never going to what? Come back down and intersect, right? So I know this picture is sufficient to see how many solutions? 2, if you know what a square root's supposed to look like. In a square root, you're going to find out in section 1.3 that it has a starting point, and then it just slowly rises if it's not flipped over the x-axis, and goes forever in this direction. So knowing these two patterns, what these two graphs look like, you know that these are the only two intersections. Happily find them. So there's got to be more than just button pushing. All right? And then the other idea of, what if this is a V, but I don't see one of the intersections? What if my picture just shows this, and then I just see this, and then just a little crook there? Is there another intersection? Yes or no? Expand your what? Window. That's what you have to be. You have to be more than just a button pusher. You've got to understand what you need to do in order to find these things. Then we got more things to talk about that, but that's good for now.